All right, so now we're going to do an example finding volume here using disks. All right, so find the volume of the solid by revolving the given region. So our region is going to involve these two things about the given axis. So we're going around the x-axis. So the best thing to do whenever you're doing these is to sketch a picture. All right, so what does the square root of x look like? Well, the square root of x is nothing but, well, we know what sine looks like, right? Or excuse me, square root of sine. We know what sine looks like. Sine looks like this, right? And just keeps on going. And it keeps on going this way too. All right. Now, if I take the square root, you can't take the square root of a negative number. So that eliminates these pieces that are underneath the x-axis. And then taking the square root just makes these guys shorter, okay? Because you're taking the square root of each of your y values. So they just get shorter. So this is what it looks like. And it's going to go from 0 to pi, all right? Because that's what sine does. This doesn't affect the period of the graph, all right? Because sine is 0 to 2 pi. So, of course, this first little piece of it, the piece that's above the x-axis is 0 to pi. All right, so we want the area between this function and the x-axis. So between this, so it's going to be this little half moon thing. So we want to take that area and rotate it around the x-axis. So we're going to go this way around the x-axis. So this is going to come down here, and it's going to rotate and be like a sphere, okay? So we want the volume of this thing. Okay, now it's not totally a sphere because it's not perfectly circular, but it is going to look spherical to us. It's going to look like a ball. All right, so now I want the volume of this thing. So the volume formula is the integral from a to b pi and then times some radius equation squared and then dx. Okay? All right, so I'm going to go from a to b. Well, I already know I'm going from 0 to pi, so that's pretty easy. And then it's pi and then some radius squared and then dx. So I just have to figure out, as these little discs go around, all right, I need to draw my rectangle. My rectangle's, whoops, come on, change the red. All right, my little rectangle is right here, down to the x-axis, okay? So this little rectangle gets rotated around the x-axis. So it's going to come down here, and that's creating these little discs, okay? So the radius of this disc, it's always going to be top curve minus bottom curve. And in this case, your bottom curve is going to be your axis. It's always going to be either a function minus my axis, or it's going to be my axis minus the function, because it's just going to be top minus bottom. All right, top minus bottom. So I'm always going to do just like I did with area. It's going to be the top curve minus the bottom curve. So I'm taking this curve, square root of sine, and the area between that curve and the x-axis and rotating it around the x-axis. So to get this length right here of how big the radius is of each one of these discs, this radius is always going to be top curve minus bottom curve. One of those, either the bottom or the top, one of those will always be my axis that I'm going around, okay? So my top curve is square root of sine of x, and my bottom curve is the x-axis, which is 0. Okay, now that looks a little redundant to put minus 0, but you'll see here in a minute why I want you to always think of that. The axis will be one of these things. It'll be either 0 minus the square root of sine, or it's going to be square root of sine minus 0. It's always going to be one of those two things. The axis will always be in my radius r. All right, so now I'm just going to do this. I'm going to solve these by hand. We're not going to math 9 them. All right, so I'm going to have 0 to pi. I'm going to simplify this. If I take square root of sine minus 0, that's square root of sine. Then if I square it, I'm just going to get sine. All right, so now I'm going to do the antiderivative. So the antiderivative, I keep my coefficient pi. The antiderivative of sine is negative cosine. All right. And then I don't need the plus c because I'm evaluating from 0 to pi. So now we do the fundamental theorem of calculus. So I put a pi in, so negative pi cosine of pi, and then you put 0 in, negative pi cosine of 0. Now we just evaluate these two answers. All right, so this would be negative pi times, well, the cosine of pi, think where you are on the unit circle at pi, you're at the point negative 1, 0. So your cosine is negative 1. Minus, and then we're going to have negative pi times the cosine of 0. So when you're over here at 0 on the unit circle, you're at the point 1, 0. So that cosine is 1. So for my final answer, I'm getting pi plus pi. So the answer is 2 pi, or as a decimal, 6.283. So if you actually typed into the calculator this integral, if you actually put it math 9 into your calculator, or even this one here, you don't have to put the minus 0 in there if you don't want to. All right. If you just put this integral in the calculator, you're going to get 6.283. And we always round to 3 decimal places. 1, 2, 3 decimal places every single time. So 2 pi, or if you math 9'd it, you round to the 3 decimal places. All right, so now problem number 2. First thing you want to do always is sketch a picture of what you got. So here what we want to do is we're taking the parabola x squared plus 5. So a parabola x squared plus 5 shifts it up 5. So we're looking at this. And then x equals negative 1 is a vertical line at negative 1. X equals 3 is a vertical line at 3. And then the x-axis, okay? So I've got the parabola, the vertical line at negative 1, the vertical line at 3, and the x-axis down here. So this is the area that I'm going to do between all 4 of these functions, because these are the functions that's creating my region. So the area within that function. Now I'm going to rotate that area around the x-axis. So we're rotating this around the x-axis. So this little funky shape is going to come down here like this, and we're going to rotate in a circle. Okay. So if I take one of my little rectangles, here's my little rectangle, it's going to come down here and it's going to rotate in a circle. So there's what one of my little discs is going to look like. I know I'm a terrible artist. All right. And my radius is this here for each of my little discs that's rotating, my slices of this shape that I have here. The radius is the part that's in the shaded region. That's my radius. All right, so how do we find the volume of this object that's going to be this big circular, looks like an anvil or something like that? All right, the volume is going to be an integral from A to B. All right, in this case, it's going to go from negative 1 to 3, so that's not too bad. Pi, and then our radius squared dx. All right. Now, our radius, I've already told you, is this distance here in the shaded region. So we always do top curve minus bottom curve. So my top curve is the x squared plus 5 minus the bottom curve, which is the x-axis, which is y equals 0, is the x-axis. All right. So we're doing x squared plus 5 minus 0. And we don't have to think about having the minus 0. I just want you to remember, it's your axis you're rotating around, which is y equals 0. That's always going to be in your R. I'm just trying to get you to think. My axis, whatever I'm rotating around, that number is always in my R formula for the volume. Remember, your volume is A to B, pi, and then some radius function squared dx. And in this radius function, inside this function, your axis is always in there. Okay, I just want you to know that. Okay, now, this will be negative 1 to 3 pi, because I'm going to do these by hand. All right, not thinking that the minus 0 is there. I'm just doing x squared plus 5 squared, right? All right, so x squared plus 5 squared, if you think of Pascal's triangle, it's 1, 2, 1. We're squaring this. So we start at the front, we square that, that'll be x to the 4th, then x squared, then no x's, x squareds, right? And then at the back, we start with 5 squared, which is 25, then 5 to the first, and then no 5s. All right, so that's what we're going to get there when we multiply that out. So we're getting -1 to 3 pi times, this will be x to the 4th plus 10x squared plus 25 dx. All right. So now I want to do the antiderivative. So my antiderivative is keep my coefficient. The antiderivative of this would be x to the 5th divided by 5 plus 10x to the 3rd divided by 3 plus 25x to the 1st divided by 1. I don't need the plus c because I'm going to evaluate from -1 to 1. All right. So now we do our fundamental theorem of calculus. I'm going to put a 1 in here. Don't forget about that little pi dude. All right, so if I put a 1 in here, I'm going to have 1/5 plus 10/3 plus 25. And then I'm going to do the same thing, put -1 in here, so there's pi times something. So I'm putting a -1 in here makes -1/5. And then this will make, putting a -1 in here will make -10/3. And then here, putting a negative in here will make -25. All right, now I know pi is multiplied times all of this. So all of this stuff, see pi is times all that, pi times all that. So I know there's pi times all of this thing. All right, but let's look at what our numbers are. We have 1/5 minus -1/5, so that's going to be 2/5. And then I've got 10/3 minus a -10/3, so that's going to be positive 20/3. And then I've got 25 minus -25, so that's going to be plus 50. All right, so my final answer is all of that, which is a 2, because 1/5 and 1/5 is 2/5. So I've got to add all this together. All right, and I'm doing this by hand to show it to you first. All right, so I'm going to write all these as fifths. So 15ths, I mean. I'm going to write all these things as 15ths, because that would be my common denominator. So multiplying by 3, I get 6. Multiplying by 5, I get 100. And then this needs to be multiplied by 15. So 15 times 50 is 750, I believe. Yeah. All right. And then all of this has been multiplied by pi. So when I combine all that together, whatever that wonderful number is, that's going to be 856 pi over 15. And hopefully I got that right. All right. I think I did my math right. Let me find my answer. Well, I'm not getting the same thing. Let's see. Did I not put the right number in? Did something? Oh, dang it. I wish y'all were here. Y'all could have helped me. All right. This was a 3. I don't know why I changed it to a 1. So y'all were probably hollering at me. Can't hear you. I can't hear you. You're not here in the room with me. So when I put a 3 in here, that changes my numbers because I didn't get the right answer because I changed my limit of integration. All righty, so let's change this. I know y'all were trying to holler at me, Miss Star, Miss Star, Miss Star. You changed it. It's supposed to be a 3. But that's an easy fix. All right, so when I plug a 3 in here, 3 to the 5th power is what? 243 over 5. And then putting a 3 in here, that's going to be 27 times 10 will be 270 over 3. And then putting a 3 in there will give me 75. Now we're in business. All right, so now let's see. I got to do the same thing I did. I'm going to make them all 15ths, and let's combine them first. So I've got 243 fifths plus another 5th makes 244 fifths. All right, and hopefully y'all checked my math. Let me just check 3 to the 5th just to double check that I make sure I do that right. Yeah, 243. Okay, and so then here I've got 270 over 3 plus 10/3 would be 280 over 3. And then the 75 plus the 25 makes 100. There we go. All right, so now hopefully we get the right answer this time. We should. So now I'm going to make everything 15ths, right? So I'm going to multiply this guy by 3. So 244 times 3 gives me 732. And then multiply this one by 5. So 280 times 5, that'll be 1400. So that'll be 1400 over 15. And then 100, if I write it as 1500s, that'll be 1500. If I write it as 15 over 1500 over 15 is 100. And then all this is multiplied by pi. So now when I combine my like terms, I should get the right answer. So what have I got? This is 29, so 36, 32. Woohoo, that is the right answer. Now, if you math 9'd it, it's going to give you 760.684. All right. So if you math 9 it, that means if you were to just take even just this first integral that we've got up here, make sure you put -1 to 3 instead of -1 to 1. -1 to 3, just type that in the graphing calculator for math 9. It's going to give you 760.684. All right. So let's do another, and hopefully I won't put the wrong limits of integration. All right, find the volume of each solid by revolving the region around the given axis. Okay, so again, I always want to sketch what I'm looking at. So I've got 2 minus x squared. Well, we know x squared is a parabola that's a smile. A negative flips it over and makes it a frown. And then adding 2 is going to shift up the vertex from the origin to be at 0, 2. All right, so that's what that looks like, shifting up to 2. All right, then I've got g of x equals 1, which is just y equals 1. So that means there's a horizontal line right here at y equals 1. Y equals 1. And then I'm rotating around y equals 1. So I'm taking this little crescent moon region here, and I'm actually rotating around this line y equals 1. So I'm taking a parabola that's intersected by a line and taking that little crescent moon region that we get between the two of them. And then I'm going to rotate it around that same line, y equals 1, rotating it around that same line. So that makes, this is going to come down here like this, and it's going to make kind of like an egg shape, right? So where are my little rectangles? Here's my little rectangle, my little red rectangle. I'm going to rotate it down to here, and it's going to rotate around. So that's what my little discs look like. All right, so my radius is created by this shaded region that I have, right? That's my radius. All right, so how do we do the volume of this object? Well, it's an integral from A to B. Well, I've got to figure out what this A is and what this B is. I need to figure out where these two things intersect each other, right? So I need to figure out where does this equation equal that equation. So again, that's 2 minus x squared, 2 minus x squared equals 1, because I want to know where the two of them intersect each other. So I set them equal. So then I'm going to subtract this over to the other side. So that'll give me negative x squared equals, subtracting 2 over here gives me -1. Then I'm going to multiply by negative, so x squared equals +1. So now I know the square root of that is 1 and -1. So if you take the square root, or you could factor it if you wanted to pull this over and factor it, you would have x squared minus 1, you're factoring that. X squared minus 1. And so you would factor x squared minus 1 into x plus 1 and x minus 1. So you could do it that way too. So your two solutions, x equals positive and -1. So that means -1 and +1. So those are my two x coordinates where these two things intersect each other. So we're going to integrate from -1 to +1. All right. So now I need pi, and then my radius squared, and then dx, okay? So how do I get my radius of the little discs that are being rotated around? Again, the radius is the length of this shaded region, which is going to be top curve minus bottom curve. It's always top minus bottom curve, no matter what. All right, so top minus bottom curve. So the top curve is the parabola, so 2 minus x squared. And then I'm going to subtract the bottom curve, which you notice is our axis. And the bottom curve is y equals 1. So we're going to subtract 1. So top curve is the parabola minus the axis, which is 1. Okay, so remember the axis is always in this radius every time. So since we're rotating around y equals 1, there has to be a 1 in this r of x. Either it's the parabola minus 1 or it's 1 minus the parabola. It just depends on which curve's on top. And we're going to do a different one here in a minute that has it switched around, I believe. All right, now, so now we're going to do this long-handed way. So this is the integral from -1 to 1, pi. I'm going to simplify this in here first before I square it. So 2 minus x squared minus 1 is going to be 1 minus x squared because it's just 2 minus 1. Now I can multiply that out real easy. Square this binomial. It's 1, 2, 1, right? And then we square the first term, so that's 1, 1, no ones. And then we square this term, so this is going to be x to the 4th, so we'll have an x to the 4th. Whoops. X to the 4th, x to the 2nd, because you're squaring it, then you're not squaring it, right? You square the last term, and then you go down. So this is squared, not squared would be x squared, and then no x squareds at all. And then if you need to write it out on a sheet of paper, if it's better for you to do it like this and FOIL it out, that's what I suggest you do if you need to do that better. Now, since this is subtraction, this will be a product, will be plus, but the middle is going to be negative. So my answer to this, before I do the antiderivative, is going to be pi times 1 minus 2x squared plus x to the 4th dx. All right, now I'm ready to do my antiderivative first, okay, before I do the fundamental. I was getting ahead of myself. Before I get to fundamental theorem. All right, so I keep my pi, okay. I'm going to do the antiderivative. So the antiderivative of 1 is x. Then minus 2, the antiderivative here is going to be x to the 3rd over 3. Then plus the antiderivative here to be x to the 5th over 5. And I don't need s plus c because I'm going to do limits of integration from -1 to 1. So now I do the fundamental theorem of calculus. So I'm going to plug a 1 in first, which those are my right limits this time. All right, so I got pi times, plugging a 1 in, it'll be 1 minus, putting a 1 in here, be 2/3 plus, putting a 1 in here, be 1/5. And then now I'm going to put -1 in here. So I've got this pi. Got this pi here. Now I'm putting -1 in here. So -1. Putting a -1 in here is going to make a negative answer times by -2. So it's going to be positive 2/3. And then put a -1 in here. -1 to the 5th is still -1. So -1/5. All right. So let's combine all this together. Everybody's multiplied by pi. So let's just combine our coefficients here. So this is going to be 1 minus -1. So that's going to be 1 plus 1 is 2. And then I've got -2/3 minus 2/3. So that's going to be -4/3. And then I've got 1/5 minus -1/5, which is going to be plus 1/5, which is 2/5. All right. So again, I'm going to change everybody to 15ths to make this nice and simple. All right. Changing to 15ths, that'll be 30 because 30 over 15 is 2. Changing this to 15ths, I'm going to multiply by 5, so that'll be minus 20. And then changing this to 15ths, that'll be multiplied by 3, so that'll be plus 6. So what are we getting? 16 pi over 15. Is that the right answer? Sure is. Yes, we did right that time. And then if you multiply that all out, you get 3.351. All right, so if you were to math 9 this up here at the beginning, like I've said every single time, if you math 9 the problem that we set up, you'll get 3.351. And then you can always check all your math and algebra that you're doing to make sure that the actual answer you get does equal your decimal approximation from doing math 9. All right, okay, I'm going to do 5 of these, so there's 2 more. All right, now this one, the reason why I'm doing this one is because I'm turning it sideways. All right, I'm turning everything sideways. So this graph is a sideways parabola. And you just have to think of some ordered pairs here. What happens when y is 0? Well, when y is 0, x is 0. What happens when y is 4? When y is 4, x is also 0. So up here, this would be 4. All right. And then also I think of what happens, how can you get an answer of 4 for x? Well, that would be if you put a 2 in for y. If we put a 2 in here, that's going to be 8 minus 4. So 1, 2, 3, 4, 2. So I've got this sideways, not as pretty as it could be. It's supposed to be a sideways parabola. Let's see, I don't know if I can make it go better that way. It's supposed to be a nice little smooth sideways parabola. So that's not bad. All right, so there's my little parabola. Okay, now I've got x equals 0, which is the y-axis. And then I've got y equals 1. So then I've got a horizontal line here at y equals 1. So I've got the region in between all three of these. So in between the parabola, the y-axis, and the line y equals 1. So it's this region here. Okay, that's the region I'm doing. Now notice I'm rotating around the y-axis. So I'm going this way, rotating around the y-axis. So this weird shape right here is going to rotate over to this side. I don't have room to draw the whole thing, but it's going to be over on this side. It's going to look like, I don't know, a part, kind of like an onion or something. All right. So what am I rotating? I'm rotating these little rectangles that look like this around the y-axis. So my rectangles are going to go around this way, right? So my radius is in the shaded region, this part right here. This is my R, my radius. All right. So how do we do volume? Well, it's an integral from A to B, and then it's pi, and then my radius squared, and then notice we're going around the y-axis, and all of my functions are in terms of y, so we're doing a dy, which means my limits of integration need to be y values. So remember, this equation right here was y equals 1 right here. This was y equals 1, and the parabola intersects up here at 4, so we're going to integrate from 1 to 4. Now I need my radius. My radius that's spinning around the y-axis is the distance or the length of this shaded region. Now, since I'm sideways, instead of doing top minus bottom, we're going to do like we did with area. We're going to do right minus left. So we're going to do the right curve minus the left curve. So the right curve is the parabola minus the left curve, which is your y-axis, which is the equation x equals 0. So that would be 0. Okay, so anytime you're using the x or the y-axis, you're using 0. All right, now, so to simplify this, I'm going from 1 to 4, pi, and all I've got to do is I have to just square this guy right here. All right, so when I square this guy right here, it's going to make y to the 4th, because I'm squaring him. And then I'm just going to do it a different way. Then my middle term is I multiply and double. So if I multiply these together, I'm going to have y cubed negative 4y cubed. So I double it, make it negative 8y cubed. And then this term squared is going to be 16y squared. So that's the same thing as doing my Pascal's triangle thing. All right, square the first term, square the last term, multiply them together and double it. All right, so now I'm going to do my antiderivative. So keep my coefficient pi. The antiderivative is y to the 5th over 5 minus 8. This will be y to the 4th over 4. Keep my 16. This will be y to the 3rd over 3. I don't need the plus c because I'm going to evaluate from 1 to 4. All right, so there's my antiderivative. So now I can do my fundamental theorem of calculus. So I'm going to put a 4 in first. So all these guys have a pi in front of them. So I'm going to put a 4 in there first. Lo and behold, do I really want to do that? Okay, 4 to the 5th. I don't, that's 256. I can do that in my head. No, 4 to the 4th is 256. So 4 to the 5th, 4 raised to the 5th is 1024. 1024 over 5 minus, notice this is 2. And then if I put a 4 in here, 4 to the 4th, 4 to the 4th is 256. And then I'm timesing that by 2. So minus 512, because that was just 2. and then plus, and then 4 to the third is 64, and 64 times 16 is 1024, and then that's divided by 3. Okay, so that's putting a 4 in there. Put a 4 in there, 4 to the third power is 81. No, 64. And then 64 times 16 was 1024. So it's 1024 divided by 3. All right, now the easy one, go put a 1 in there. Okay, so I'm putting 1 in there. It's pi times all this stuff, putting a 1 in there. So putting a 1 in there is 1/5. Putting a 1 in here will be -2. Putting a 1 in here will be 16 thirds. All right, so it's much easier putting smaller numbers in there. Okay, so everybody's multiplied by pi. So what I'm going to do is take the pi out, and now let's combine the like terms. So I've got 10/24 minus a fifth. So that's going to be 10/23. And then I've got a -512 minus -2, which means we're adding 2. So that'd be a -510. And then here we've got 10/24 thirds minus 16 thirds, which is going to make 1,008, I believe, thirds. 10/24 minus 16, check my math there. 10/24 minus 16 is 1,008, yeah, thirds. All right, so now, again, if I was going to make this problem a little easier for myself, I would put everything as a common denominator. 3 goes into this, though, so that will make my common denominator a whole lot easier. All right, 1,023 minus 510 plus 1,008 divided by 3. That goes in evenly. 1,008 divided by 3 is 336. Ooh, that makes our math so much easier. So now we've just got 336 minus 510, which is -174. So pi 10/23 minus 174. All right. So now to simplify this, I'm going to change everything to fifths because I want to do it as an actual answer first. All right. So that would be 1,023 minus, changing this to fifths is 174 times 5 is 870. So my answer is 1023 minus 870, 153. So 153 fifths times pi. Woohoo, that's the correct answer. All right, and so if you math 9 that answer is 96.133. 96.133. And just so you know, when you're doing this on the AP exam, if this is a free response question, once you do the fundamental theorem of calculus and put your numbers in here, this is your answer. You're done. You don't have to do any of this simplifying. I'm just showing you how to do the simplifying so that like you can check your answer with the back of the book or something. All right. So you can always math 9 it, check it with the back of the book, that kind of thing, either one of those. But remember, with a free response question, once you do your fundamental theorem of calculus and you plug in the 4 and you plug in the 1, you quit. So I don't want you freaking out. I'm just trying to show you all the algebra, that it is possible. We can do this. Yes, we can do math. We can do simple algebra. All right. And then you always want to math 9 it and check your answer to make sure you are correct, to make sure you're not practicing incorrect steps. All right. So the last one I wanted to do, number 5, is another one turned sideways. Okay. Another one turned sideways. So we're in y again. So we've got x equals 1/4 y. So if it's hard for you to graph these, I just plug in numbers. Like if I make y 4, that means x is going to be 1. So that would be 1, 4. Right? Now let y be 4, that would make x 1. So that's the 0.14. If I let y be -4, then x is going to be -1. So that would be -1, -4. So I just plot numbers. So it's this straight line, right? And we knew this was going to be a line because it's just x equals 1/4 y. That was going to be a line of some kind. All right. So now, then I've got y equals 2. Y equals 2 is a horizontal line. Y equals 2. And then y equals 5 is another horizontal line. All right, so y equals 5. And so we're taking that region of the line between y equals 2 and y equals 3 and the y-axis. That should have been in here too. So we're taking this region here. So between the two lines and this line, x equals a fourth y, and the y-axis, and we're actually going to rotate it around the y-axis, okay? So about the y-axis, so we're rotating around the y-axis. Okay, so to do this, we're sideways, okay? We're sideways. So our volume is going to be from A to B, pi, and then our rate. I always just tell people to do this, do your setup first. So let's see, we're in y, so I know it's going to be dy. So that means my limits of integration have to be y values, so that's going to be from 2 to 5. And now I need my radius. So if this thing is rotating around the y-axis, that means this little piece is going to come over here, and we're going in circles. So my little rectangle that I'm rotating is the width of this distance of this shaded area. So that's my R. All right. So since we're sideways, it's right curve minus left curve. So right curve minus left curve. So my right curve is the 1/4 y, and my left curve is the y-axis, which would be x equals 0. So not too hard a one. So we're integrating from 2 to 5 pi. I can go ahead and square this because this is going to be easy to have squared, to do squared. 1/4 squared is 1/16, and then y squared is y squared. Because we can just ignore the minus 0. All right, so there is our expression. All right, so now I'm going to do my antiderivative. So I keep pi over 16 since that's my coefficient. The antiderivative of y squared is y cubed over 3. I don't need plus c, and I'm just evaluating from 2 to 5. So now I do the fundamental theorem of calculus. So I plug a 5 in first. So I'm going to keep my pi over 16. Plug a 5 in first. 5 cubed is 125 over 3. Then I'm going to plug a 2 in. So I keep the pi over 16. Plug a 2 in. 2 cubed is 8 over 3. Notice my denominator is 48 in both cases. And everybody has a pi. And so I'm just doing 125 minus 8, which, what is 125 minus 8? 1 something. 125 minus 8, 117. Yeah, 117. All right. Let's see. By 3. Yeah. All right. And so, because this can be reduced to 39 pi over 16, because you can divide by 3. All right. And if you math 9 that answer is 7.658. All right. So that is doing volume by disk method, by disks. And so you just have to remember your formula for volume of a disk. It's just pi and then some radius squared. And inside your radius, it's always going to be a function minus your axis, or either it's the axis minus a function. It's always going to be that to find the radius of these disks that get rotated around, because your radius is just the width of that shaded part of the area that's really being rotated around the axis that you're doing. All right, so you've got a couple problems you can practice, and now you'll need to watch the washer video on how to do those kind of problems.